Hi, everybody. Nathan Frank. I'm currently the Director of Machine Learning Platform and Operations at Grainger. And how I like to drink my coffee is really any way I can get it. But, I have a machine that does like a simulated pour-over experience for me. And that makes pretty decent coffee, I think. But I'll take diner coffee any day as well.
What is up, good people of Earth? This is another edition of the MLOps Community Podcast. I am your host, Dimitri Ose, and today we're going to be going on a journey with none other than my friend Nathan Ryan Frank. Woo. This conversation, we get into it. We talk all about MLOps and software engineering, what Nathan's approach is to building tools and how he looks at if there is a tool that's already on the market, should he incorporate it into his stack, what the trade-offs are there, what's the same in ML versus software engineering, what's different, and how he approaches that, how he approaches MLOps from the DevOps perspective. And then we get into teams and communications, what the common language gaps that he's seen have been when it comes to different teams speaking different languages. Maybe that's a product team or a product individual that's trying to talk to a machine learning engineer or a data scientist. What common language can they use that will bridge these gaps? And how he sets up, how he's seen the most success for teams and what their constitution looks like. Last but not least, we talked a little bit about his personal life, did some rapid fire on some of the good stuff that he does in his free time. Hope you enjoy this conversation with my man, Nathan Frank. And as always, we would love to get a review from you to help us just boost them rankings in the Spotify algorithm so that the whole world can go and listen to this episode about MLOps. I know there's probably a few people in Kansas right now, probably middle-aged women that are thinking, you know what I need right now? I need some MLOps in my life. And you hitting the review or giving us a incredible 5 stars on whatever your app you're listening in on right now, that will make sure that this app sends it out to those middle-aged women that are missing MLOps in their life. I can feel it. So hit that review, give us the like, and I'll see you on the other side. I mean, I have to start. I feel like it is not fair to not start with the idea of this telescope that you helped build. And what is the story there, dude? You've got astronomers, students, and people all over the world that are leveraging this. Give me the breakdown.
Yeah, so once upon a time, I was an astrophysicist, I guess you could say. That's why I studied in undergrad, physics with a constant, for concentration in astrophysics. And then I went to grad school for physics and astronomy. And the research group that I aligned myself, led by Dr. Dan Reichert at University of North Carolina, Chapel Hill, the research goal was around these objects called gamma ray bursts. So these massive explosions, they emit the amount of energy that our star will emit over the sun will emit over the course of its lifetime in seconds. So they're just incredibly massive, super energetic explosions. Usually happen when like a massive star either collapses into a black hole or two former massive stars collide with each other. Anyway, so that was the research goal of the group. And that's ostensibly what I was trying to study and trying to model and understand the behavior and how do we, characterize them and all this kind of stuff. But in order to do that, he built a number of telescopes, a handful, about 8 in the Chilean Andes. And then while I was there, we built installed another 4 in Australia. I say built as a misnomer because these are largely like what you would describe as high-end amateur components. So like if you had the proper funding, you could go into magazines and like order this stuff and put it together. And all of these were part of a network called the Skynet Robotic Telescope Network. And so they had, and again, a lot of this predates my joining the team, but they built, all the software, sort of local software to control the hardware, move move the mount, move the telescope, change between different filters, and operate the camera, and all this kind of stuff. And that was accessible by a web interface. So as a user, you could log on to the skynet.unc.edu. You could have a username and password. You could say, I want to go take a picture of whatever, Jupiter, Saturn, this random object at these coordinates. And it would go into a queue. And when it got dark, and if there was a location that your object was visible with the settings that you desired, it would go and snap off an image or images of whatever you requested, and it would go back into and return to you in your interface and like in the web interface. And so I learned a lot from that. Just about one, it was incredibly fun to go to the Chilean Andes and be up on top of the mountain, to go to the Australian sort of not in town in Australia, and kind of be out there, and definitely some fun stories with some of the truckers that brought some of our stuff. Truckers in Australia are a unique breed. They're pretty I don't know, you just can kind of imagine they're pretty kind of seen it, and pretty rough and tumble people. And so it was just really cool. It was learning a lot about how do we get all these interacting components to talk to each other? How do we understand how to move the data through? It was my first exposure to an actual software system that's running. It has users, and you got all these parts talking to each other, and you got to move the data from one place to another, and then you got to surface it in an actual analysis application, processing, all this kind of stuff. So I think it really sparked in me an interest in, or sparked an innate interest in software, in building software and building technologies, and that interface of theory or research and actual end user applications. And that's kind of, I think, was one of many turns in my career. But that was one where I was well, I'm in grad school ostensibly to go get a PhD in physics and maybe spend a career in academia, but maybe that's not really what I want to do. And so I kind of came to this realization that I'm either going to go teach high school math and physics because I really like working with students and want to just, spend the time with the students, or I'm going to go to industry. And I ended up going to industry, leaving my program actually, and going to work with sports and data and doing some interesting stuff there. But yeah, it was very fun to work on. Very cool experience.
Is that how the transition happened into ML? You said, all right, I'm going to go work in industry, and turns out, unless you're working for SpaceX or NASA, or even if you are, I guess they're not really hiring a lot of astrophysicists. So you said, what's the next best thing? Sports and betting. Was there betting involved?
So there was not, I should say, I've never been super interested in betting on sports for whatever reason. I'm into math, I'm into statistics, I'm into machine learning, and I'm into sports, but I never really combined the two in any way that was lucrative, I guess. No, I think the way it happened is that I was kind of looking around, and I had never, again, my wife said this to me after the fact, how did you never have this realization? I never thought about oh, I really love math, I really love basketball. Is there a world where I can combine these things? It just never. And she makes fun of me to this day because I said, well, I never, if I thought about working in the NBA, I thought I'd be playing. And not I thought I was going to play in the NBA. I'm a realistic human being. I'm not even 6 feet. I was never going to be a professional basketball player. But what I meant was I didn't really think about these other careers that might, I just didn't have the awareness that there were other things you could do to be around sports. So part of it was this sort of mental transition of oh, what does industry look like? What are the things about studying physics that I'm really enjoying? What are the things about, the data analysis or, the problem solving that I like, and what kind of career paths are there? And then sort of simultaneously at UNC at the time, there was some groups working on basketball analytics stuff. And so I just kind of got involved as oh, that seems really interesting. Let me kind of tap into that. And it ended up sort of being this career path that I was able to find. And so yeah, that was kind of the transition.
And it started as analytics, but it went into and evolved into machine learning?
Yeah, sort of. So it started from a very much sort of traditional data science or sort of statistics and analytics place. There was a professor that had started a conference, a basketball analytics conference specific to kind of that analytics piece. There, there's a big, the Sloan Sports Analytics Conference. There's a big conference in the space, and now is kind of runs the gamut from sort of which is very business analytics, to like very advanced machine learning and like tracking and like computer vision. Like there's a whole bunch of things that play into this now, but this was a very small, like very tailored, centered around students a lot, and a lot of just open conversations. So that was my first foray, and I started kind of just doing some side projects, looking at simple things, higher level numbers, for very analytic, like more analytical than predictive, I guess. And one of the people that came to the conference ended up being my future boss. So I just started talking with him about, he had showed some things they were doing on basically using tracking data. So, data about the motions of players and the ball, and trying to do that to do essentially like play search, right? So you kind of have this visual representation of like a sequence, and then you try and show me everything like that, this play or, that sequence. And they had been applying it both to soccer or football, and non-American football and basketball. And I thought that's like, I've never seen anything like that. That's really fascinating. So I just got to talking to him about it, and eventually ended up getting my first sort of post-grad school career there at a company called Stats LLC at the time. Now they're called Stats Perform.
So I got to ask.
And I think that's when I started doing more actual machine learning.
One of the things that I think the American announcers get a lot of shit for abroad is that they don't really announce or commentate on the games. They just basically run through a bunch of stats. And you always see especially in American football games or in an NBA game, at some point in the game, you'll get the announcer saying, this is the first time that this has ever happened. And they go through like, they slice and dice the data in a way that it's like the amount of free throws that have been hit by a guy from Slovakia with his left hand. It's the first ever, And so
I remember.
Was that you? Do we have you to thank for that one?
Okay, so me specifically, maybe not. I mean, this is the type of thing that the company of Stats, now Stats Perform, that did, and they did it in a few different ways. A lot of it was individuals who were just really knowledgeable and passionate about sports. And so they would actually, like when things would happen in a game, they'd be like, I wonder like how many times that's happened before. So those types of things that you're calling out, sometimes that's just a human who's sitting there watching the game and is providing basically this research support to broadcasters. That's one of the things that Stats did. And so they'd be there watching the games, I think sometimes even at the ballpark or the arena or wherever. And they'd be like, that was really interesting. Going out and they'd query it. We had access to the data, so they'd construct a query, they'd figure it out. And as you highlight, sometimes they're so esoteric that they almost become meaningless. Like I remember it was a Chicago White Sox game, and it was like, this is the first time that 3 outfielders named Rodriguez have all been on the field at the same time. And it's like, okay, I guess that's interesting, but like, is it really? Like, what does that really mean about, is that really interesting about the game? Like, it is an interesting factoid, I guess. But
yeah, exactly. It's exactly that.
Yeah, but there were some attempts to try and like automate that, or try and build models around predicting or defining what is interesting, and like a few different approaches. There's sort of the like anomaly detection approach, right? Of just like, how do we in everything that's happened in this game or everything that's ongoing, how do we find things that are unusual, right? Statistically unusual, right? So that's one way you can go. And there's another approach of like, what do people actually find interesting, right? And so you can get some explicit or implicit feedback on these insights or these facts, right? You can kind of, maybe you tweet them out and you use like engagement as some proxy for interest, right? Or maybe you actually ask people on some like 5-point scale, let's say, this is not at all interesting to this is very interesting. And then you could try and have, sort of a 2-part system, generate these snippets maybe, or like highlight these things, and then try and predict whether or not people will find it interesting. So there's something, sort of data driven to that's kind of an interesting problem.
So this is a perfect segue into one of the other things that I wanted to talk to you about, and how you approach building machine learning systems, and specifically like the tools and platforms that go into that, right? Because you're talking about basically like getting human feedback there from someone on, hey, is this interesting? Is this not? That's one piece of the puzzle, but there's a lot that goes into that platform and that system before it even gets to where a human can say like, yeah, cool, or no, that was boring for me. You've designed many systems. I know that was like your beginning of your career. Since then, you've designed many other ones. How do you approach it now when you're looking at, okay, we need a tool or we need a platform that is going to help us do XYZ to get this machine learning product or this AI product out into the world and creating value for our company? What does that look like?
Yeah. So I think there's like a practical approach that I try and think about, which is like, how much pain is it causing us to do this? Or like how much churn is associated with some aspect of this process, right? Like there's an approach of like, oh, there are these tools and there's all these tools out there. There's all this development in terms of, these new products and these tools. And I solve this problem and Y problem, but like, you got to know that you have a problem to solve first, right? And undoubtedly, if you're a company that's really anywhere in your sort of ML or AI journey in terms of adoption, you probably have problems that some tool might solve. But it's just a question of, where do you go? Do you bring in that outside tool, or do you try and like pick away at it internally? So yeah, for me, it's like, is this a one-off thing? Is this going to be a repeated problem? Like, have I done this once before? Is this only the second or third time I'm doing this? And I should probably look at how can we maintain this and sustain this in a way that is like repeatable, that we have some standards in place, that things that are alike should largely look alike in broad strokes. And by that I mean that like the mechanisms, the kind of the structure, how things fit together, how they flow, you're getting like deployment pipelines or CI/CD pipelines, or how you can sort of compose services. The structure of that should largely look the same, because you want it to be easy for people to become familiar with them, right? Undoubtedly, you're going to have people moving into and out of working on these systems, and you're going to want to change them. And the easier they are to understand, and the easier they are for people to onboard to, the easier they're going to be to kind of change, right? And some of that requires some of those structures in place, best practices around, project structure and sort of CI/CD and testing and all that kind of stuff. But some of it is just like understanding where your team is at, or where your user, I mean, if you're building machine learning platform tooling, your users are all internal, where they are at, and trying to meet them somewhere that's reasonably comfortable, right? Because we could shoot for perfection. We can shoot for like the absolute by the book, this is how things should be. But if a lot of your team is coming from a research background, for example, and they're only like sort of familiar with Git best practices, for example, it's going to be really challenging for them to go from that starting point to perfection. And there's going to be a lot of bumps, and there's going to be a lot of like, well, this is in my way, and I can't really, like, I want to learn this, but I can't do it fast enough. And so I'm just going to fall back to doing it the way I'm comfortable with, and I'm going to kind of put it to the side, and I'm going to hide it under the rug, right? And so I guess that's part of my approach, is trying to think about understanding who are the people are, what kind of problems are they working on, what tools are they working with, what's comfortable today, and trying to think about, okay, how can I make this easy, right? Do I need to build out some templates so it's very easy for them to just have all these things in a structured way for all their projects? Or do I need to develop some internal SDKs? Maybe those SDKs are just simple Python libraries that are a bridge between, some new system and kind of what they're familiar or comfortable with today, right? And that's kind of where I start before I say like, hey, there's tool X, and we need tool X because tool X can do X, can do ABC 1, 2, 3. Because it's hard. It's hard to bring in a new tool. It's hard to onboard users. It's hard to get them to change from something that they are using existing to move to something new. And so there has to be compelling, and it has to be easy, right? There has to be like clear, tangible outcomes, and it has to be easy. I mean, and you can always come down with, the hammer from above and say, no, this is the new tool. You got to use it. And that's an approach. And there's, there are times where I do think that like, you kind of got to push people a little bit, right? You need to push them to change, because we are creatures of comfort and creatures of habit, but it has to be, what you're asking of them has to be reasonable.
Are there places that you feel like you can generalize and say, like you were saying, like CI/CD is always a great idea, right? No matter what your use case is, no matter what your end users are doing, that is a good thing to have, probably a need to have, not a nice to have. Are there other things in the ML workflow that you feel like is a must-have these days? And I understand that, 2-3 years ago, it may have been completely different. You probably were working with people or data scientists who were like, hey, we're tracking everything in Excel. And that was cool. That was good enough because the maturity levels may not have been there. But now, as we feel like maturity levels are much more mature, for lack of a better word, what does it look like? What are the need to haves and things that you can generalize no matter what, if it's a computer vision problem or if it's a just straight tabular data problem?
Yeah, so some sort of deployment pipeline, promotion pipeline and deployment pipeline, right? So, and part of what that assumes, I guess taking a step back, part of what that assumes is that you have some standard in place, some structure in place for how people develop and iterate on their problems, right? And so one of the things that I think about as being standard for an ML stack is a bridge from notebooks, a bridge away from notebooks, right? I mean, or something around codifying that notebook. People have different opinions, and we're not going to get into the notebooks in production debate, but people have different opinions about this. The way I think about it is that, like, notebooks are a really great tool. They're a great tool for exploration, for getting something, an idea out fast and iterating on it. But I want it to be very easy for people to abstract that work, right? So that they can then share it very easily in a package, let's say, or in, a container, some other shareable asset, that other people can come into it and have a clear understanding of how to interact with it. Meaning that if it's just kind of in a long stream of consciousness sort of notebook, it's not always easy for people to come in and put themselves in wherever your headspace was and understand your context. So pulling that out, abstracting where you can, putting testing around it, unit tests ideally, but integration tests, where they're appropriate, and then having a release process for that, right? Every time having a clear sort of policy around this is our sort of our branching strategy. Again, just trying to make it easy for people to adopt those standards. And so sometimes, depending on the tool you're using, that can be a little bit tricky, right? Like some tools are I've worked with Databricks a lot in various contexts, and that's a tool that's very interactive. Like it's very much built around being in the UI and pointing and clicking and developing in notebooks, and then I'm going to build a workflow that points at that notebook and so on and so forth. And I think that's great from Databricks' perspective as a company that wants to sell a lot of software and enable users, because it's very easy. But so then how do I find that middle ground of like, yes, that's easy, but also like it's very easy for then things to get lost and for things to not be tracked and for us to not be able to reproduce things, for us not to be able to deploy things easily and move them from whatever we're going to call this dev environment to some higher environment like production. And so that's where I talked about sort of templates and internal SDKs, very simple wrappers that kind of foster that process of saying, great, you did this cool thing, you sketched it out, you have this idea. It should be very easy for you to take that idea and encapsulate that in a project structure, and be very easy for you to sync that with some Git remote. It should be very easy for you to apply that to other workspaces or other environments. It should be very easy for you to take that idea and operationalize it, like put experiments around it and run through experiments and track the outcome. So standards, project structure, get best practices, testing to me is a standard. I know it's not always easy for people who don't come from a software engineering or software development background to get their head around testing, especially for machine learning. But there's so many areas where it's really easy to put in good testing practices and guard against your future self and make it easy for other people to understand your code. CI/CD pipelines, and then again, these light integrations, right? Like make it very easy for people. You talked about like experiment tracking Excel. People still do that. People still, even when they have tools available, they'll still do it just because it's comfortable and easy. And so that's where it's like, I need to make it easier for you to use MLflow. MLflow is a great tool. It's so easy to use. But if you've never used it before, it's the new thing. It's the cognitive load that you have to take on and like inject into your process. So how can I make that as easy as possible for you? Like ideally, you don't have to do anything. MLflow has done a great job of like all these auto loggers that they have now, and they work to varying degrees. If I understand how you're building things, if I understand the frameworks and tools you're using, hopefully it's a no-op for you. It's not even a thing you have to think about. It just kind of happens, but that's not always possible.
Yeah, it reminds me of this whole idea of the cultural aspect on things. And if somebody is comfortable with the Excel, then they potentially aren't going to realize that, oh, wow, it's just this easy. And all I have to do is, these 1 or 2 extra steps, whether that's in MLflow or Neptune or weights and biases. And now I have this new world that's opened up to me. And from there, what's beautiful is what I've seen other companies do is they'll have like almost I don't want to say like peer pressure, but they'll have just like the days where different data scientists can hang out with other data scientists and they get to exchange notes on what they're doing that's working, how they're doing it. Or you have something like one of the community members, Stefan, he's now an internal developer advocate going around teaching the users of the ML platform how to use the ML platform better and how they can leverage it. And it's like, they don't have any strong rules as to you have to use the ML platform, but he sits there and he says, well, if you want, you've got all these benefits. Here are some of the benefits. And he's teaching these different data scientists or consumers of the platform how to leverage the platform better. And so I could see that. I mean, now I do want to ask you about something that you glossed over, and I know that you love it, your love for tests, and explain what the tests look like and how you go about writing them, and why do you like writing tests so much?
Yeah. I will talk about it. The dev advocate role is an important one. And I think you hit on it. I think it's huge because just to kind of put the final point on that last sequence, I think that if you're building an ML platform, right, people should want to use it, right? And it shouldn't be painful for them to adopt, right? And so that's another kind of how I think about it is like, how can I make this look so cool and so attractive and so easy and so beneficial that I don't have to push people, that like adoption is something they want to do. And so that finding people who are good at that education and training piece and can like, hey, here's this full example. Let me walk you through it. And here's like, like how easy it was. And here's now I have all my experiments and I can compare them and I can yada, yada, yada. So I think that's a huge role. So I appreciate you saying that. Testing. What do I love about testing? So again, I started my career as an academic. I was in physics. I was doing research, but writing a lot of code, writing a lot of software, and never wrote a test for a long time. And started seeing some tests again with some of the components that the broader team, the software engineers on my team in grad school were building. But I didn't really have an understanding for kind of where it fit because I wasn't like day to day, in the trenches like working on these systems. I was more consumer. I was, kind of helping on some of these build trips. But when I got to stats, I primarily was a data scientist. So I was primarily working on these, research questions, trying, specking out new ideas. But then when there was the occasions where it's like, hey, we have this whole, this data science pipeline, it's an analytical pipeline, basically taking all these raw measurables about, what happened in a game, sporting events, at the game level, or even like at the, individual play level. And we want to creating all these derived measures for them. Things like, likelihood to score in the next X seconds or something like that, right? That all comes from some enrichment on top. And there was basically this opportunity like, well, we need to go and we need to embed with the engineering team that's going to build out this ETL process. But we need someone there that's going to like sit with them to kind of help, answer questions, understand. And I was just like, yeah, that sounds interesting. I'll do that. And that was my first like foray or very like, deep dive into software engineering best practices and like things like paired programming and testing and various types of testing and even like, various stages of deployment pipelines and sort of like trunk-based development. I'd never sort of done that before. And like just kind of, yeah, everybody's working together, but as long as you're sort of doing things, with this assumption, with this mindset that we're all kind of, working on in this way, that it all works out. And I think the thing that I really took away from it was a few things.
Hey, I'm Vishnu. I'm a data scientist at Firsthand, and I definitely think that you should subscribe to the MLOps Coffee Sessions podcast. It's the best podcast out there to stay on top of what MLOps actually is, to talk to the true thought leaders in the space. And oh, by the way, Demetrios is absolutely hilarious. What a weird guy. You should definitely subscribe to the podcast.
Like one, I had never written in Java before, and all the ETL pipelines were in Java. And so I'd taken some classes in C++ once upon a time. I primarily worked in Python, but I was like, kind of just like, okay, I'm pairing with someone like a Java developer, a Java engineer, having never written Java before in my life, but I could do it over time, right? Because there was this structure to the way the things worked, and there was this entire testing environment where I could go look at example tests. We're trying to make a change to this part of the code base. There's this class that does this piece of enrichment with this method, and we want to go update it to now do something else, right? And so there being all these tests, they provided that example. They provided that context to understand, okay, I can kind of look at the syntax now, and I can, the syntax takes time to learn, but like I could understand the structure and how things were structured and how they operated and how they interacted. Because I had that kind of safety net of tests, right? So that's one thing I really love, and why I really advocate for testing is, and testing early. Like, you don't necessarily have to do test-driven development, but you need to integrate testing early in the process. Because the thing you constantly hear, especially in the data science, the ML community, is like, well, if this idea gets to production, that's when I'll like write tests, and like that's when I'll put tests around it when I'm going to go productize it or whatever. And the problem is that like that's 3 months later. You've lost all context on what you were thinking, right? When you were writing that feature engineering pipeline, right? Or that transformation logic. And like, you could probably come up with some decent examples after the fact, but when you're in the context of like, oh, cool, I had this idea, this is the feature we need, I'm going to develop it, this is how I'm going to do it. That's when you have the context. And so that's like another big piece of it for me, is that like, it saves you time later on. It's such a time saver later on. And like I get with ML, because it's so much of it is speculative, that like that is a little bit like, it's not obvious, it's not black and white, right? There is a little bit of nuance to like, do I need to like what level of development of an idea is appropriate, and that's where I like try to bring back to the sort of project structure thing. That's why I try to build all these tools around pulling stuff out of notebooks and encapsulating it or abstracting it, because that is the time, right? If you are pulling it into a Python, module, or if you are pulling it into a project structure that you're going to then go push to a remote, like that's the time.
You need tests. That's great that you have a clear idea of, all right, it's all fun and games, exploratory mode when you're in the notebook. And I see 100% this idea of you have it so fresh in your mind that it's very clear to you what tests need to be written and don't need to be written. And so as soon as you come out of that notebook, you're like, you're not going anywhere without writing at least some kind of test that will help us all get context and understand where your head's at.
Yeah. And there's also like there's so much good cognitive feedback from writing tests. Like I think that people don't understand until you've like gone through the process of like, I wrote a test, that test is failing, my IDE is lighting up red, I adjusted things to make the test pass, and now it's all green. I get all these like very satisfying little green check boxes on my work, right? Like it seems silly, but it is very satisfying. It's like mowing your lawn or something. I don't know. It's like raking leaves or something. It's like a very satisfying.
Yeah, it's a dopamine hit.
Yeah, it's a total dopamine hit for sure.
It's basically how developers do social media dopamine hits, basically. We don't have to go on Instagram and get likes. We just have to make our test pass. So
write more tests, make them pass.
Just
right.
Write more tests, get more dopamine. That's a new shirt. I like it. So, dude, well, I do want to talk a little bit about the kind of drifting over into the cultural side of things. The thing that you mentioned about teams falling down or not performing to their highest ability a lot of times comes down to people not understanding each other's languages. And so when it comes to machine learning projects, I think we all know that there's a lot of stakeholders, whether it is on the business side of the house or it's on the technical side of the house. You just were talking about how data scientists come into things with their whole preconceived notions. And then you have software engineers who may be coming into something with this test-driven development. Everything has to be tests. Or you have data engineers who really like to write in SQL or things like that and just want to figure out the best way to move around this data. And then you have the product teams or the product owners who have their ways of looking at it. And so what roles have you seen people speaking different languages in, and how have you remedied this, or how can we bridge that gap?
Yeah. One of the most successful from my perspective, from a development perspective, ML teams that I was part of was at Stats Perform. We were basically building out a ML driven API for sportsbook operators. So you asked about betting before. I've never bet on sports myself, but this is a very clear need. Gambling on sports became legal in I think 2018 in the US, and so we basically had this remit to take some of what we were doing and build out a service, that was trying to provide these predictions, of things like number of points an individual player was going to score in a game, right? And provide those predictions pre-game within some window with some likelihood of happening, right? And so, there was certainly some data science and machine learning work to build out those models and how do we understand how things happen, sort of generally for the average player versus this specific player, and understanding some of those. So there's a lot of interesting data science and machine learning work that went into that. But the team that built that out as a service, this is meant to be an API. It was consumable by sportsbook, by whoever, and had all these different sort of triggers for updates too. And that was kind of one of the complications, because if you're talking about the sports betting world, there's a lot of things that can cause a huge shift in what you might predict, right? Case in point, if a LeBron James is listed out for a game, that's going to super change your predictions for the entire team, and even probably the opponent team, right? So you got to understand how all these different triggers play in and be able to update very quickly all these predictions. So there's a very real, just architectural challenge to this. But one of the things that was so successful about just from a development perspective and building out this service was that we were a fully integrated team. And that doesn't always work, but in this case, it worked really, really well. So there was data/ML scientists, what you would call ML engineers, sort of full stack software engineers, a technical lead on the ML side, a sort of engineering manager type person, and a product owner, all on one team.
One of each?
Some in varying degrees. So technical, I was the tech lead on sort of the ML, or kind of for the whole project, more on the ML and sort of some of the engineering side. And then there was an engineering manager that I partnered very closely with, and a PO. And so we were kind of a triangle, right, of different spheres of influence, but a heavy amount of overlap in various ways. So you talk about defining stories and defining the work and prioritizing work. That was a collaborative process between the three of us. We were able to sort of cover gaps and understand we've got to think about X, if we're going to do that. Or, obviously the product owner was the best suited to say, hey, I just met with one of our, sort of potential clients or one of our early clients, and they said, one of our early customers, and they said, oh, that they really need this feature. And so we kind of got to prioritize that. But I don't really know how to, how do we fit that in, and what is the impact of that change, right? Not everyone's going to have all of that in their head necessarily. I think there's some really great technical product owners and technical PMs that can do a lot of this, but I think kind of that collaborative approach is really important. And then we kind of like daily stand-up. Everybody was there. Everybody kind of had this shared concept, right? So all of that process, that development was very shared. And there were some cases where you kind of had to look at it and be well, there's a front end component to this. We had a front end interface for essentially the human in the loop predictive process, right? And so there was an interface for humans, experts, to sort of enter things like the amount of minutes a player was going to play, like adjust those, because that was really hard to predict. And so like maybe we wouldn't have a data scientist or ML scientist pair with a full stack engineer to work on like a Vue, or React app. Like that just didn't necessarily make sense, right? So there's a little bit of like, yeah, we're not all working on the same things all the time, but there was a good amount of overlap and a good amount of like pairing and shared context. And so there was a lot of things that came out of that. Like one, we were able to move really quickly because we were kind of all together, all had shared context. Two, like a lot of the sort of ML engineers or ML scientists really learned a lot and got upskilled in their software engineering best practices. And then similarly, some of the sort of software engineers who maybe didn't have any background in machine learning and had never really worked with any of the frameworks or tools that like, that ML engineer kind of sits in the middle, they would have exposure and they'd have some really great ideas about like, oh, well, once they kind of understood how these models are processed or what are the triggers or what are the kind of requirements, they'd have some really great ideas about how we can break these things apart or how we can start architect the system, right? And that doesn't always work, right? You can't always support a team, that like dedicated of a team, depending on kind of your suite of products and how many you have and how many you have, do you have the capability to sort of just embed a resource like a data science or ML resource with this product team? But that was one of the most successful sort of from a development and then, ability to kind of iterate perspective. And it really reduced that productization or operationalization gap that often happens when you have data scientists or ML scientists, or even ML engineers working on some model, working on something, and they say, okay, great, I'm here. Like, it looks good. This is a great idea. We want to put it into production. Engineering team, here it is. Like, what do you need to know, right? And then I was this whole process of like learning and getting that shared context and like going through iterations of like, oh, I did X, Y, Z, and it's like, oh, but that like we looked at the data and it's not quite right because you forgot whatever. I don't know, whatever the case may be. There's that lack of shared context, and so that was the big kind of thing that came out of that was there was a very minimal gap. There was very little translation that needed to happen. And people were able to then work together rather than saying like going back and forth asynchronously.
Yeah.
Over a course of weeks. So some of that is fostered by tools, right? Like this was pre-feature stores, basically. Like I think midway through that project is when Tekton was like in early trials, and they were, kind of not the first, obviously, but one of the early ones to really kind of pull this concept out very, very widely around feature stores. And I think that that's fostered close some of that communication gap. If you bring in a feature store, sometimes it's a nice communication medium where data scientists can maybe own those feature definitions all the way through, but that's one part of it. That's not everything, So there's still benefits to working together.
It reminds me of a talk that Ewan Nicholson gave, I think probably like now 2 years ago. And he was mentioning how he felt like before where you would have, and he did it very visually. He had a slide and he said, let's imagine you have all these different job titles and each one of them has a respective like color, like a rainbow on, like stripes as it goes across the slide, where all software engineers or back-end full stack, whatever you want to identify as, you have the red sliver. And then the data engineers have a yellow sliver and it's all yellow where they are. And then the machine learning engineers are purple and the data scientists are green. And what he said is how when he decided to break up the teams and try to find that shared language, and he spoke about it a lot like you did, if I'm understanding correctly, it's like, can we create a team and embed data scientists with engineers, with machine learning engineers and data engineers and software engineers, all of that, so that it's its own little unit, as opposed to having the machine learning product team servicing the data scientist team. He was mentioning how that when that happened, they started to find that shared vocabulary and the colors stopped being so defined and it became like a gradient as opposed to very clear, like, here's the yellow, here's the blue, here's the purple type thing. It's like now it's a nice mix and you're not really clear on the colors because a full stack engineer understands what a feature store is. And a data scientist also understands what a feature store is. And so they can say feature store and they both go, oh, okay, that's like decoupling these feature definitions from the code or from the models, whatever it may be. And so that just exactly what you said, it reminds me of that perfectly. Like, oh, now it's a gradient type of view as opposed to very clear like slices of colors.
Yeah. Or there's even a time where like if I were to say serving or inference, model serving or model inference, like that would like I don't really know what that means. You know, if there'd be engineers on the team, I don't really understand. And so it took some time, like you said, for us to kind of get to a place where there was that shared language. And I think part of the reason I liked it so much is just I experienced it firsthand, right? I experienced everything that I was able to learn and develop as a broad range of skills in software development, software engineering, and ML system architecture from being a data scientist who was like, yeah, I'm going to go embed with a team, with ostensibly a software engineering team, and I'm going to just be really confused a lot and learn a lot. And you know, I think it's similar to how, you know, a handful of years, you know, maybe 10 or 15 or I don't know, however many years ago, DevOps and like infrastructure were dedicated in separate teams. And to varying degrees, they still are in a lot of organizations, but I think it's much more common today for software engineering teams to own their DevOps pipelines, right? To say, whatever you're using, GitHub Actions, Circle CI, or whatever you're using, that they understand and own the process of deploying their code from local to remote and between environments, right? And similar for like owning their infrastructure, right? If you're using cloud and now you're using infrastructure as code, like it's less common for them to say like, okay, team A, can you please go provision me, these pods on a cluster or an EC2 instance or whatever it is, and then I'm going to go deploy give me access and I'm going to go deploy. No, like if you're building a thing and it requires infrastructure, if it requires deployment, you should own those definitions. You should understand how they work. You should be able to kind of take your thing from end to end. And I think that specialization that silos those teams off, breaking down some of those walls. I've seen it happening in various ways in data science and machine learning. I think it's generically a good thing. And it's sort of a similar trend a little bit.
Yeah. Now, I want to go through some rapid fire questions with you in these last 5 minutes. And I'm going to start with a book that has impacted you the most in your career.
I don't know if it's the most in my career overall period, but one I read very recently is Accelerate.
Is this spelled accelerate with an, oh no, it's actually
Accelerate.
Spelled properly. All right, nice.
Just the word Accelerate.
Yeah, exactly.
So great book, really, complement to like the Phoenix Project or the DevOps Handbook, any of those. Like, I think just as I've kind of come out the other side of maturing around sort of building systems and DevOps and kind of understanding that from firsthand, it's a great sort of like summary of those principles and a look, like a very data-driven look at what the impact is. So
what's the coolest or most challenging ML system you've been a part of building?
At my last company, I'll plug Strong Analytics, data science and machine learning consulting firm, very cool bunch of people doing really interesting stuff. We were asked to build essentially a product identification service. So, the ability to like snap an image of some store shelf product or something and then be able to identify. And the thing that was so challenging about it was, one, the machine learning aspect of just, the computer, combining these computer vision and search techniques and vector database and being able to kind of organize all that. But it also had to be compartmentalized by groups of users, essentially like some context, like a store or a company or whatever, so that there was very clear guards around data. And so just building all the systems to kind of like spin up a new stack of this was really, really challenging and really interesting.
And then it all got replaced by LLMs and
no comment.
Hopefully not. Hopefully not. Hopefully not.
There's some amount of it. I mean, there's a system aspect, right? Like whether you whether you're running your own models or that's an API you're calling, there's still like a lot of moving pieces that you have to understand how to piece together, right?
Yeah, that's a great point. So last one for you. I know you're an outdoorsy guy. I know you got 2 dogs and 4 kids and a wife there. What's the most fun or /scariest hike or backpacking trip you've ever been on?
So I did, undergrad was at UC Santa Cruz. So I was on the West Coast. Spent a lot of time in Yosemite. So I guess I have a multi-part answer. One time in the fall, a bunch of buddies and I, we went and we hiked up Yosemite Falls, which is normally like in the spring, a 2,000-foot raging torrent of water that falls into the Yosemite Valley. But in the late summer and early fall, it's basically dry. And so we actually hiked down the riverbed, which you're probably not supposed to do, and sat basically with our feet over the edge of Yosemite Falls. And it was absolutely terrifying. I am not a big fan of heights, so it was like, took a lot of convincing to get me even close. But it was just this very like the wind coming up. It was this very like surreal experience. And then we did another backpacking trip on the Lost Coast Wilderness, which you have to go look up where that is. But we ran into a pack of elk along a very narrow trail between essentially like the cliffside, and that was on one side, and then like the actual drop into the ocean was on the other. So there was nowhere we could go, and we just kind of had to like hang out with this pack of like 30 or 35 elk are massive animals. So we're like, I don't want to spook them and have them like run us down. But that was really, really beautiful, really fun hike.
Wow. Incredible. Well, thanks, dude. I think we'll end it there. And for anybody that wants to reach out to you, we'll leave all the information in the description. This has been awesome. I really appreciate you coming on. I knew it was going to be great. I appreciate it.
I appreciate it too. Like I said, I've been around the community for years and just love what you're doing. I go in every day and look at, MLOps question answers and sometimes try and help and answer, but sometimes I'm just reading and learning things. Yeah. There's so much happening. So I appreciate that it's a community that's there to leverage.
Yeah, and I got to thank you. I mean, you're just as much a part of it as I am, right? Like your answers, you helping people also helps me learn. And so I'm very happy that we got to do this.
Ops. You have to immerse yourself in the MLOps content. The best way to do it is to subscribe to the MLOps Community Podcast. So, good luck and keep learning.